Hi all, welcome to our new session. This is Fawaz and I'm here with my buddy Lasinda. And we are here today with an amazing project, which is AWS three-tier web using Terraform. So what we will be doing is we will be creating a web or three-tier web setup using Terraform in the AWS environment. So, if you don't know who I am, my name is Fawaz CP. I am a DevOps engineer working in a Hitachi Systems India Limited company. And I'm also an AWS community builder since last 1 year. And I'm also got AWS Certified Solution Architect Associate. So, Lasinda, I would like to give an introduction about yourself.
Okay, Pavas, thank you very much introducing me. I'm going to introduce myself a little bit. I'm Lasanta Sanjiva. I'm from Dubai. I work as a IT engineer. Also, I'm a second year AWS cloud builder, and also I'm a AWS certified solution architect. I'm happy to that work with you doing the school project because these days Terraform is very famous. Our team is today apply today because everyone try to apply Terraform today. That's the one. Cool.
That's very nice introduction. So, this is the architectural diagram that we are going to implement today. So, Lasinda, just give an explanation about this architecture.
Okay, Pavas. Uh, First of all, in AWS given workshop to create this 3D architecture using AWS console, we are going to demonstrate to how to create the same architecture using Terraform. That is the main thing. We need to help community to learn and grow Terraform skills. And first of all, I'm going to demonstrate this, discuss this architecture. In this
Yeah.
architecture, developer push the code to Terraform, like Terraform is script. After that, behind the scene, automatically everything provisioning, every resource in AWS cloud, EC2 instance, load balancing, RDS database, S3 buckets, uh, user profiles, credentials, everything. First of all, inside the architecture, they are having 3 tiers like app tier, web tier, and database tier. In application
Yeah.
tier, that one database logics and everything application related stuff we doing inside this application tier. In web tier, in user expose the web tier. It means that we run application using Nginx and exports to outside world end user. And next, we use load balancing because we need to balance the load and auto scaling purposes. We use auto scaling groups. And first of all, I'm going to discuss this architecture. We deploy it inside the VPC because now the time we need to we consider AWS cloud the main and basic thing in every resource we created inside the VPC because VPC is very most important. And after that, firstly we create VPC, next create subnets, and next create route table and load balancers, everything. I now I'm going to demonstrate step by step this architecture. Uh, I will firstly we need to create this VPC. Next, we going to create subnets, VPC and subnets and load balancer. Next, we need to create NAT gateway to expose our private instance to internet. Next, we're going to create app tier, and inside the app tier, we need to create one EC2 instance. We use Amazon Linux, and you can use Ubuntu also. That is also fine. Ubuntu, any Linux distribution. Next, we create a database for manage store our SQL related database queries. Next, we create also we try to create S3 bucket. We're going to store our credential code samples in S3 bucket. Next, inside the S3, we're going to copy this S3 to EC2 instance, our app tier code, database tier code, Nginx configuration like this. Next, we configure internet gateway and like this security group for security purposes, like expose report like this. And next, finally, we create load balancing and create internal load balancer for app tier to connect with web tier. Next, create public load balancer for web tier to expose to outside world. That is our main architecture. However, over to you start the demonstration. Thank you very much.
Thank you so much, Lasanda, for explaining this architecture diagram. So as explained, Lasanda, that everything has we are going to create using the Terraform, but this video is going to be two parts. So in this part, we will be demonstrating till creating, setting up the web tier. So we will be sharing the codes with you how you can do it, and I will just open that first. Let's give me a moment. Lasanda, just please let me know if you are able to see my screen, the GitHub steps. Hello.
Yeah, I can see
Lasanda,
your
can
screen, brother. Yeah.
Okay, so before doing this, we always suggest you to do this activity using AWS Management Console individually. And if you are very new to Terraform, then first do it in the AWS console manually, then come to Terraform. So in order to do this, the first step we have to setting up the code. To set up the code, we can download it from the GitHub using the this URL. So what I'll be doing is I'll just open VS Code. I think the VS Code might not be visible to you. I'll
Yeah,
have to
yeah,
reshare my screen again.
yeah,
Is it
yeah.
visible?
You need. No, no. You need to share screen. I think so. It's
Okay,
open in one tab only. Google Chrome.
just give me one moment.
Yeah. Meantime, I will share this URL also in WebT Architecture AWS workshop. Firstly, try this architecture in console. Next, you try to do this project. We recommended that because firstly, you need to get AWS console experience.
Okay,
After the
so
session, we
now,
put in this your link is in description section. You can go in through that one. Also, over to you. Start demonstration.
oh yeah, I have opened the VS Code right now,
Yeah,
and just let me know if you're able to see it.
yeah, I can see your screen.
Okay. So I'll just change here from PowerShell to GitHub. So I have created a new folder. In order to create a new folder, you can select here on File, then you can click on Open Folder. Then here you have an option to create a new folder wherever you would like to. Then select that folder from here. Then you will be able to see the folder. So right now in this folder, we don't have anything. So just PWD, make sure that you are in the same directory. Then after that, I'll just go to my GitHub and I'll just copy the URL to clone that repository where our code is existed. So this is what I need to do. First, we will clone this repository. Once we clone this, just LL to verify that it has been cloned. After that, I will just get inside this directory. Mm. So in the setup, we'll have to create an S3 bucket as well. And well, let's see how we are going to create the S3 bucket. I think this one is not working. I don't know what happened to this. Okay, let me open the
Okay.
terminal. Uh, okay, yeah, I'll just change the directory to this and let's verify all the files are code or application code and the other codes are here.
Okay. Cool.
So, so in order to create the S3 bucket, we will have to create a new file with extension S3 bucket, or sorry, with the extension of TF. So what I'll do, I'll just say use touch command to create a new file.
Yeah.
You can see that file has been created over here. Then we need to copy this code and make sure you have to change the bucket name because bucket name should be unique for each and every user. So
Yeah. Yeah.
I am in
Focus.
the US East. Yeah. So I am in the US East 1 region right now. And if you prefer to use different region, you have to make sure to stick with that region and you have to edit that region as well. So once you paste this, you have to save this using Control S. And the first command we will have to do is Terraform init in order to do or install the required Terraform
Yeah. Pavas, I want to add,
initialization.
Pavas, I want to add one thing. Before going
Yep,
to copy this command and everything, you need to firstly install the Terraform and AWS CLI
correct.
mandatory to install. And firstly, then try to create a user and next get the access tokens keys and next try to configure the CLI in your PC. Next try this power methods. That is better, I think, because otherwise this command is not working. After the
Yep.
session, we will put the description how to install Terraform and AWS CLI links,
Mhm.
everything in the description section. Powers over to you. Going.
Yeah. Yeah, that you have to make sure if you are getting any error while doing Terraform initializing, or you are not able to connect with AWS, which means the AWS CLI has not installed and the Terraform lab has not set up. So in order to create the Terraform lab, I have already written a blog. So I can share that link in the description as well. So once we have done the Terraform init command, the next command we will have to do is we have to validate. So what this validate command will do is whatever the Terraform code that we have written here. So it will validate whether this code is correct. And if there is any error in this code, we can see that error over here. Right now, for me, there is no error so that you can see it is success. So once the validate has been done, so I will just use another command, Terraform plan. So Terraform plan, this command we are using before applying any resources to the AWS. So we will have to see what and all things needs to be done using like what and all things is going to be added, what and all the things going to be changed, and if any resources are going to be destroyed. So right now we have only one thing to add, which is the S3 bucket creation. So we are good to create the S3 bucket. So I'll just write Terraform apply auto approve. You can just write only Terraform apply also. When you apply, you do only Terraform apply, it will prompt you to enter yes. So I don't want it to prompt that each and every time when I do Terraform apply. So that is the reason I have used Terraform apply. So let's verify it on AWS Management Console. Listen that let me know if you're able to see the AWS console as well.
No, but the AWS console not coming. Okay, now come. Yeah, yeah, cool.
Okay. So this is the bucket that we have created right now. And yeah, it is in the same region, the bucket name. So once the bucket has been created, let's see what is our next step. Next, we need to set up an IAM role for the EC2. Okay. So this IAM role, we are creating it for our EC2 instances in order to connect the instances we wanted to install any packages. Then we will have the IAM role. And in order to connect with the S3 bucket also, we need to have the IAM role for the EC2. For that is the reason we are creating this IAM role. So what I will do, I will just go to VS Code once again. And just let me create a new file called touch IAM role.tf. Make sure the extension should be tf. The
Yeah,
file
yeah.
name you can keep anything, whatever the name you would like to. So once that has been created, I'll just copy this from here and I'm gonna paste it over here. So let's verify it. And this time I'm going to introduce you one more new Terraform command, which is Terraform format, FMT. So what this format will command do, let me just give some examples over here. So I am just keeping it in randomly somewhere and you can see, and I'll just save this. Okay. So right now there is no format mistake. So what I'll just write this command again. So you can see the Terraform automatically fetch that format and it has kept how the format should look like. Then I will just validate this as well. Let's see if we are having any error. So we don't have it. It is success. And we can do the plan command once again. It will show you what resource is going to be added at this time.
Okay.
There are 4 resources going to be added, and if you scroll up, you can see what and all the 4 resources are going to be created. So there are a few permissions with one IAM role is going to be created. So I'll just apply it using Terraform apply auto approve command. It may take some time to create it. Once it has been created, we will be able to see it from the console again. We can verify it. Okay, I'm getting some error. So let's see what is that error. Oh, where is that error? Okay. Come on. So
Yeah,
IAM 3-tier operation IAM question. I think the error is because I have already created an IAM role with the same
yeah, yeah,
name.
yeah,
So,
yeah.
so I'll just copy it from here and I'll go to my AWS Management Console and open the IAM. Then if I go to roles and I can search store here. Oh, sorry, the copy first. Come on, man. Okay, that is not the name. What is our IAM role name?
Yeah,
Okay.
role name going to that.
So it
Yeah,
was created already. I was doing some, of course, the practice before this demonstration. So I forgot to delete this one. So if I delete this, we will be able to create that. We won't be getting that error. So it is always good that we are getting error. So whenever if you are getting any error, you can just read it from here. What is that error is? So based on that, you can be able to do troubleshooting from your end as well. So what I'll do right now, I will just apply it again. Sometimes when you do plan, there won't be the if you might can't be able to see that error, but in the approve, it will get some error. So if you are getting plan, everything is okay, doesn't mean that there won't be any error.
yeah. Now I think so that is creating. Yeah.
Mm, no,
Uh,
okay.
uh,
1 second.
I think so. Uh,
There are some error we are getting it.
yeah,
Let's
brother. I
see.
think so. Try to change the name in amrol tf file. That's better because sometimes this
Yeah,
happened
it
in.
is. Okay. Okay. It is, we are still getting the same error entity already exists. So what I am gonna do is I'll just change the name as Rasunda I suggested. Okay, so I'll just mention it here new. Also tag also we can mention it new. The rest everything is looks good. But I think 1 second, AWS instance profile, 38th line. This name should be changed, I guess.
Yeah, yeah. This name also need to change. But
Only
now
this name
this,
needs to.
yeah. But now this name not affect. I think so. Better to try like this now.
Because it is specifically given that here is where we are getting error. So what I can do is I will not make any changes. Rather, I'll just change the name over here. Um, rather of 3, just kept it like this. Then applied. Before applied, you can do plan, but we have not received any error in the plan. So let's see, it's this time it is working. Hopefully we don't get any error. Yep. So
Yeah,
that is the problem.
everything.
Whenever if you get any error, what needs to be done is, if I can see that, you have to see, it will also show you in which line or what is the error. So you can go to that line and you can just see. So it has already mentioned that the name already exists in that. So we have changed that name, then we were able to complete it. Now if I just search it, I can refresh this. You can see that IAM role has been created. Once that has been done, I will go to my GitHub. And the next thing that we need to do, we have our code in our local, right? So that application code needs to be upload into our S3 bucket that we have created. So you can do it in 2 ways. So the one which you can see it here as var, because if you're setting up var, you can mention that. But yeah, let's see. We can create our variables also, which is also fine. Here, I will just create a new file called variables or vars.pf. Then you can see that over here, and the variable name is going to be S3 bucket, WS3 bucket. So I will have to get that 1 second. I think we can skip this part rather than creating variables. We can just mention the bucket name directly.
Yeah, I think that is better because that can otherwise going to complicate.
Yeah, we will be showing creating another project related to Terraform where we will be explaining about the variables and modules. Right now, we can go with the straight thing. So I'll just upload this into the same S3 bucket. So we don't need to upload this one because we have already created an S3 bucket. So when next we need to upload the file. So copy it from here, then go to the S3 bucket Terraform file which we have created, then paste this over here. So what this is going to be do, this is going to upload. So if you see from here, you can see all these codes, application code, and inside the application code, you can see app tier. For the app, there is codes inside this, and the web, the code is inside this, and the configuration file for the Nginx as well. So these files we need to upload into our S3 bucket that we have created. So make sure you are into the same path where you have created the S3 bucket and the IAM role. So we'll just save this file and validate it. Getting some error in the which line number we can see.
Mm. Hello, Pavas. Okay. Okay.
Yes, yes.
Okay.
Calling Nginx file open Nginx system cannot find the specified file. This one we are getting error in line number 25. The Nginx file not able to call. I put asterisk over here. I don't think that work.
think, brother, this application code folders get to the root directories better because you mentioned like this only. Engineers, every time this S3 call as root folder items
Okay.
goes to
Uh,
your file directory and inside the application code, try to move this web tier outside of application code folder. That is better.
one second.
Yeah,
Uh,
yeah. Yes, you can move using command also.
okay, so you meant to say like all these applications should be moved here, right?
Yeah.
Hmm. Okay. So CPR add here and the same one I can do it for web here also.
Also, engine is fine.
And now if I go over here, we can see everything is here. App tier is there, web tier is there, and the
Engine.
Nginx config is here. Yeah. Now let's validate it again. All right. So the error that we have got is because our application code, Nginx configuration file, and the web code, it was in the different directory. So we have not mentioned that path over here. I think you could either mention that path over here, else you can move all those code into the directory where we are already into. So I will just write Terraform format and once that Terraform plan, let's see how many resources are going to created.
Okay, it's creating. I want to add one
It
thing,
is,
Pavas.
yeah,
Uh, you can see this create a resource using Terraform having one command. And remember that Terraform state list.
yeah.
After the run Terraform apply, you can check this. It is list.
So what this Terraform state list will do, it will show how many resources are created using Terraform. So right now these many resources are created. So we will be applying it, the uploading S3 bucket. After that, we can see. Okay. So it may take some time because there are a lot of codes needs to be uploaded into the S3 bucket. So we'll have to wait for that. Now I'll just run the Terraform state list. We can see a lot. To verify it, all our codes has been uploaded to the S3 bucket. So I'll just go to that S3 bucket we have created, and you can see all these has been uploaded successfully.
Yeah, cool.
Okay, okay, and the next step that we are going to do is the step two. We are getting into our step two, which is network and security. This is a very important thing, and here is where all our things are going to start. First thing, we are going to set up the VPC and the subnets, and then the security groups as well. So this is what lesson that's already explained in that architecture. Every resources that we are creating inside one VPC and inside the subnets, public and as well as private. So first, let's go ahead and create the VPC. For that, I'm gonna create a new file called vpc.tf. Then you can see that file over here, and I'll just copy it from here. And if you want to change the IP, you can change it, the CIDR value. Also, make sure which region you are already into. I have created the resources in the US East one. So the VPC also I want to create in the same region. So in this, what we are going to create, we will be creating a VPC with CIDR value. Listen, that you can explain this.
Yeah, okay, Pavas. Uh, because in there we need to create 6 subnets related to application code, web tier code, and like database. We need to every tier need two subnet because we deploy this code as integrate with auto scaling and some scalability purpose. We add two subnets. That's the reason use two subnet. Also, in this year, we mentioned in anywhere of IPv4 address, but even though using anywhere, you can use your my IP like this because that is better. Now that I'm in internet related vulnerabilities, so many things available. That's the main reason you can use not use 000 like this in anywhere IPv4. You can better to add rather than in my IP in security group.
Yes, that will comes under the security groups. So that I will be explaining to you once again. Right now that we are creating subnets, VPC and the subnets, private subnets. So let's see. From here also I can explain, or also once VPC that we are going to create, under that VPC we will be having two public subnet because we want high availability for the web application, and we are also creating two private subnet for the app, or what to say, application, which is running inside the private instance. And for the databases, we are creating a separate subnet. That also two subnets, because for that also we need high availability. Okay, so this has been created. So let me go to the AWS console and show you that VPC has been created with its CIDR value and the subnets, associated subnets with that. Okay, I haven't applied it, I guess.
Yeah, you need to apply.
Okay, I have applied it, but I forgot to save that file. That's why you couldn't see. The resource has not been created. So what I'll do, I'll just apply it again. I was also wondering why that resource has not been created. So let's wait for some time.
Okay, first I need to add one thing. In there, you need to add use same region you previously used for like S3 bucket creation. Same region use
Mhm.
because that is
Correct.
better because otherwise errors come and better to use one region for deployment. But in disaster recovery scalability purpose, you can use multi-region like this. But in this scenario, we use one region.
Yeah.
Yeah,
Even
that
though
is
that
the
we are
main.
using one region, correct. So even though that we are using one region, we are keeping the subnets into different AZ availability zone. So once that has been completed, you can see the VPC has been created and the fader value that we have mentioned. And if you go to the resources map, you can see what and all the resource has been created with this VPC and in which region. By default, one default routing table is going to be created. But again, that we are not going to use this. We will be creating the routing table for each subnets. So let's see, next step that we are gonna do, once the VPC and the subnets has been created, Slee, we have to create the internet gateway. So why need internet gateway is in order to get our VPC internet access, we will have to create and attach that internet gateway to that VPC. So in order to do that, you have to just copy it from here. You can get this from the Terraform registry as well. And you can keep it in the same file where we have kept our VPC codes. Okay. Once that has been done, what I'm going to do, just doing the same commands, first Terraform format, then I'm going to validate it in order to verify there won't be any error. Then I'm going to do plan command. If you're confident enough, you can skip this plan command and you can directly use apply command. But in production, it is always recommended to use all of these commands because sometimes in validate, you get success, but in the plan, you get some error. Whereas so that's the reason I'm using this auto approve. And it is going to create the internet gateway. Then the internet gateway is going to get attached to the VPC. So let's see that as well.
Yeah, Pawan,
You
that
can
is
see
very
that
cool.
internet gateway. Yeah, internet gateways
Good.
also get created. How cool is it, right? We can
Yeah,
see
AWS,
everything in one code also.
yeah, AWS provide this very good design because we can see everything we created inside VPC.
Exactly. So we have created the internet gateway right now, but how we are going to connect the internet for our private subnets? For that, we are going to create a NAT gateway. So I have mentioned it clearly. In order for our instance in the app layer, which is in the private subnet, to able to access the internet, that subnet needs a NAT gateway. So we will be deploying NAT gateway in each subnets for the high availability. In order to create the NAT gateway, so make sure here, from this part, you will be get some charges if you are practicing it. So you have to keep it in your mind while creating an ad gateway. Elastic IP also will get associated for that. For that Elastic IP, you will be charged per hourly basis. I think $0.05. I'm not sure about that. You can check the pricing from the AWS pricing calculator or from the AWS documentation. But if you are using it and destroying it the same time once your lab has been completed, you won't end up with more charges. So that you have to keep it in mind. So I have just added that resources over here and I just saved this and I'm gonna run the same commands again. And I'll just apply it. This time I just skip the plan command because I believe that there is no issue. If there is, we can just see and rectify it. NAT gateway creation will take some time because Elastic IP is going to get associated. And this NAT gateway that we are going to create inside the public subnet that you can see it here.
Yeah, that is creating. I want to add one thing. In Pawas already mentioned that in this architecture, you created in NAT gateway, Elastic IP, like load balancing, everything takes some cost. You need to try to your free tier account. That's also fine. They AWS given some free tier limitation. I think so. Better to try to your free tier account or try to create new free tier account because not try to in like production gate account in this architecture because that one cost some money.
Yeah. And the main thing that you may end up with a lot of charges if you forgot to forgot to uh, delete the RDS that we will be creating after some time. So the NAT gateway is still creating. It may take some more time, like I said. So Lasanda, I think the recording is going to get stopped in few seconds because I can see that.
And right now we have successfully created the NAT gateway also. If we go to the VPC under the resource map, we can see the NAT gateway also has been created. But as you see over here, the internet gateway and the NAT gateway has not been mapped with any of the VPC resources. So the first we can map the internet gateway to the routing table, but we are not going to use the main routing table. Rather, we will be creating new routing table for the public segment. So where we will be attaching our internet gateway. So to get this stuff, we need to copy this. You can copy it entirely and go to the vpc.df file. Then you can paste it over there. Just save it and follow the same command. First, we will start with Terraform validate. Let's see if you're getting any error or not. So Terraform validate has been successful. So I just apply directly without entering Terraform plan command. You can use Terraform plan command as well. So Terraform apply over. Let's wait for some time what this will do. As of now, you're seeing there is only one routing table. After this, you will be able to see two more other routing table for each AZ. Then that has been associated with in the internet gateway. So let's wait for that. It is still creating. And if I refresh this page, and if I go to the resource mode again, as I said, you could see two more new routing table has been created, and that has been associated with the internet gateway so that this public segment would be getting the internet access. Okay. So next, what we need to do once we have created the routing table for the public subnet, we need to create the public subnet. Okay. Now we can see the public route tab has been created, but we haven't added the public subnet to this. As you see, the public subnet has been mapped to the internet gateway, but which has not been mapped with the public subnet tray. So to do that, we have to copy this one. So what this will do, this routing table is going to associate with the public subnet where we have created for each AZ. So I'll just copy that and paste in the same file and save it. Again, I'll validate it, then I will just apply it. Once it is validated, you can apply it. You can also use the plan command. So I am already aware that there is no error, but for the safer side, it is always recommended to use the plan command before applying it. So once that has been created successfully, you will be able to see this public subnet or the public routing table has been associated with the public subnet in each AZ. So I'll just refresh this post right now. And if you see here, this public subnet has been associated with this routing table is in AZ1 and this public subnet is also in AZ1. This public subnet is in AZ2 and this public subnet, sorry, this routing table is in AZ2 and it has been associated with the public subnet which is in AZ2. So once that has been created, the same process we have to do for our private subnets also. To do that, just copy it and paste in the same file what we have created these things for the networking part. So I'll just save this and apply it. Before applying it, I'll just validate it for the safer side. Then I'll just apply it. So once I have applied it, rather than using this main routing table, it is going to create another two routing table for the private subnet. And it might not get associated with the private subnet, and we have to do it manually, like we did for the public subnet. Let's just wait for the creation of this. And once it has been created, we can refresh this page. And if you go over here, as I said, you can see it got mapped with public subnet also. The routing table has been created for the private subnets. So once that has been done, the next step is we need to create the security groups. Security groups actually the firewall. So we have to create the security groups in order to tighten the rules around which the traffic will be allowed over load balancer and the EC2 instances, right? But the first security group that we will be creating is for the public internet facing load balancer. And we need to add inbound rule to allow HTTP traffic from your IP. You can allow the HTTP from anywhere also, which is not an issue. And we are going to do, in order to do this, first we'll have to create a new file called security or st.tf. So what I'm going to do, I'll just create a new file and name it as st.tf. Then I'll just create security group for the internet facing load balancer. So the naming convention is like that, internet load balancer security group. Then I'll just apply it. As I said before, that I'm doing the validate all the time. Then only I'm just applying it. So once after that, you'll be able to see the security group has been created. So you can go and see that from the security group. So what I'll do, I'll just create other security groups as well for the public instances and the private instances. Then after that, we can see all the security groups at a time from the console. So once that has been created successfully, we'll copy the other security group for the public instances. Let's wait for the security groups to be created. So this has been created successfully. I'll just scroll down and paste the other security group rules. So this one we are going to create it for our web tier EC2 instance. So I'll just validate it and apply it again. So it has been validated. Now I'll just apply it. So once that has been created, the next security group that we want to create is for our internal load balancer. So we will be explaining what this internal load balancer does, why we are creating this, and what is the purpose of external load balancer also, or the internet facing load balancer. So that you have already heard it from Lisanda that during the architectural explanation, he has explained each and everything. So the same procedure that we are following over here, we are creating all those things individually. So you can come over here and paste this. So this security group has been created, and the next security group rule that I am going to paste it. This is for our internal load balancer. Let's validate it and apply it again. Once this internal load balancer security has been created, next we will have to configure security group for the private instances. So after typing a name and description, add an inbound rule that will allow TCP type traffic from port 4000 from the internal load balancer security group that we have created in the previous step. So what we need to do, we will be creating a private security group, and we will have to add a inbound rule, the port for 4000, but this 4000 should be allowed from the internal load balancer that we have created just right now. So basically, this port is our app tier application is running in the 4000 port. And what this internal load balancer will do, internal load balancer allow to forward this traffic on the port to our private instances. That's how the private instance will be able to get internet, able to connect with internet. So let's see how we can do that. So we have mentioned each and everything here. So here you see your IP where you have to enter your IP. How you can get that? You can just search in the browser that just say my IP, and here you will be able to see under IPv4. I'll just copy this and keep it somewhere for the safer side right now. And I'll just copy the entire security group resource one, and that I'm going to add it under the security group. And over here, where I have mentioned your IP, you will have to replace with your IP. Okay. Now I'll just validate it this, then I'll just apply it. After validation, I'm going to apply. Let's see, once that has been created, what is the next thing that we need to do? The next security group, we are also going to create one more security group for our database. So we'll be creating a database RDS after the security group has, all the security group has been created. But for the security, sorry, for the database also, we need to have a security group, right? To get connection with our application and with our web tiers. To do that, you just need to copy the entirely like this, then paste over here in the same file where we have created other security groups. You don't need to make any changes over here if you're following all these steps like how I did from the GitHub code. You can copy and paste it. But before copy and paste, just try to understand what and all things I have mentioned over there. So I'll just validate over there again. Once the validate has been success, I'll just apply it. So till this, we have completed all the security groups part. The next step that we have to do is database deployment. But before that, let's verify all the security group has been created or not. So once this has been successful, I'll just go to EC2 instance. Where is that? And from here or from the VPC also, you can get the security groups. So I'll just try to find out over here. Let's go to our code and you can see it has been success. And what I'm going to do, I can filter it with the name. Yeah, as you can see, all the security group has been created successfully, and you can see the inbound rules, what and all the rules that we have added just by clicking and scrolling down to what's over there. Everything will be like how we have configured. So now let's go ahead and create our database. So to do that, first I'm going to create a new file called database.df. And for the database, first thing that we need to create a subnet group. So I am adding the private subnet. So make sure always your database should be inside the private subnet. You are not supposed to expose your database in public subnet. And also make sure you are not supposed to click yes, where you will be able to see if you are doing it using console, where you have an option to select publicly accessible yes or no. It should be no, because database we cannot expose to the public directly, right? Where we'll be storing all the data. So that should be inside the private. So to do that, I am going to create a subnet group first inside the private subnet, and let's apply it. And to verify that, I am just going to RDS spawn. Sorry about that. So once this has been successfully completed, if you go to the subnet groups from the RDS console, you will be able to see one more subnet group has been created. Yeah. Now I'll just go to the subnet groups from the RDS console and refresh the page, and you can see that subnet group has been created. And to verify that it is under the private, you can verify the error block from the VPC. So these are the private IP which I have configured from the networking components. Next, we need to create the cluster. Inside the RDS cluster, we will be having one primary database and also one read replica. So I have mentioned everything, and you just only need to do one change over here. As you see, here I have mentioned var master password. So okay, I haven't added any variables so far. So I'm not exposing my password over here because your password should be you're not supposed to expose your password anywhere, right? But for the learning purpose, you can mention it the password it over directly over here. But when you are in production, if you are deploying it, you will have to mention this as variables. You can create a new file called variables and mention that password over there. But I'm going to mention the password here directly because as I'm going to delete these resources after this recording has been completed. So I just mentioned the password is admin123. You can mention whatever the password that you wanted to, but if you want to add that edit in the variables, you can just mention that password under variables and no need to expose your password in the database Terraform file. So this has been done. Now I'll just apply it. See, creating RDS will take a lot of time. I would say like around 5 to 10 minutes because there are a lot of things which needs to be configured before creating the RDS. Even if you are trying to do it from the console, you can you know that how much time it will take. So what I'm gonna do before until the database has been created, I just post this recording or the post this video Once the database has been created, I'll just come back and show you the database has been created successfully. And you can see it took almost 13 minutes to create the RDS database. Now, to confirm that, I'll just go to the databases from RDS console. And as you see, the database has been created successfully. So this is the part 1 of our video. In the next part, we will be creating our load balancer, the auto scaling group, and the rest of the steps like creating the app tier, web tier, till completing this video. So watch and do till here, and see you soon in the next video. Bye.